In this video, we're going to look at how to add up two complex numbers on an Argand diagram. So the thing to note is that we can add two complex numbers together on an Argand diagram the same way we would add two vectors together. So there's a whole series of videos in this set of videos on vectors. So if you don't know much about working with vectors or vector addition and subtraction specifically, if you go and watch the videos on that, you'll see how we do that by drawing the vectors out end to end. And we can do the exact same thing with complex numbers if we sort of treat them as vectors. So what we do is we draw them out end to end just like we would with vectors. But let's look at an example. So the question is to draw 4 plus 2 pi plus 2 plus 6 pi on an Argand diagram. So we want to just draw the point. Remember, complex numbers are just points on the plane, so we want to draw this point. Now we could just do that quite easily by just adding the two numbers up as we normally would. We add up the real parts, we get 4 plus 2, which is 6, and we add up the imaginary parts, we get 2 plus 6, I, which is 8i. So we expect to get 6 plus 8i. Okay, so that's just adding up the two numbers in the normal way. But we want to see that we can also do this by treating them as vectors and adding them up the same way you would two vectors with a diagram. So what do we do? Well, let's first mark 4 plus 2i, the first complex number in the sum. So that would be at the end of this line. So I've gone 4 along the real axis and 2 up the imaginary axis. So I get to this point, 2 plus 2i. The number is just the point, but I've drawn the line because I'm sort of acting as though they're vectors to show how I can add them up. So then I need to draw 2 plus 6i. But remember, with vector addition, you place the second vector at the end of the first and start it there. So if we do the same thing, this is 2 plus 6i. So I've gone 2 along the real and then 6 up the imaginary, but I've started at the end of the first one. So I get to this point here. So this is my complex number now here. Just like if I was doing vector addition, I would add the two up and then this length, this long length here would be the answer. So this is my answer. The line is going to the point 6 plus 8i, which, as we already said, is the exact answer we expected to find. So we can do this method, treating them as vectors, draw them end to end, and then draw a line from the start of the first one to the end of the second one, and whatever point you're at, that is your complex number.